Okay, we'll come back. All right. So, in this case, yeah, just in this circuit we have made R2 is short circuit. So, R2 is equal to 0. You can make R1 short circuit also, that all current will pass through this only, right. So, that means it will totally bypass that your R1, right. So, so all the currents will flow, I2 actually will be equal to I, right. If you make a short circuit, that is why when anything gets shorted, no, we get some anything short circuit as will happen, we get a shock, right, huge shock. Sometimes short circuit it carries huge, I mean more amount of current, because it is basically current will be V divided by the resistance of the wire, because this one will bypass. As a short circuit it gets a low resistance path, that means huge current will flow. So, low resistance means high current, right. So, similarly all these things are written here, you can read. Similarly, if it is open circuit means R2 is equal to infinity. So, there will be no current through R2. If R2 is an open circuit, that will all the current I1 is equal to I will pass through R1 if it is an open circuit, right. So, it is understandable, right. So, this is open circuit condition. So, in that case Req is equal to R1, because R2 is infinite, will your what you call your then Req will become your what you call that your R1. I mean if you do not try to multiply this, if you it is something like this, right. Suppose Req is equal to R1 R2 by R1 plus R2, right. Now, if you divide it by your what you call R2, then that will become R1, and if you divide by R1 R2, so this one I am making first, R2 by R2 1 plus R1 by R2, right. Now, if R2 tends to infinity, right, so this R1 by R2 will become 0. So, basically it is 1. So, basically it will become R1. So, that is why when it is open circuit, Req will be equal to R1, understandable, right. So, now look at this problem. So, a voltage divider connected to a load RL as shown in figure your 32, you have to obtain an expression for V0. Now, actually it is circuit is like this, I am just explaining you. Actually the problem, it is said that that you have a voltage divider circuit, across the R2 a load resistance load is connected, whose resistance is RL. Actually it is something like this, that your circuit was like this is a voltage divider circuit, this is V. So, if you take a series circuit is a voltage divider circuit, is R1, right, you have R2, right, and this is the circuit, this is R1, this is your R1 and this is your R2, right, and this is plus minus terminal, the way it has been marked I am marking, this is plus minus, this is your V1 and this is your V2. Now, across this is a series circuit, across this what we are doing, we are connecting one load, right, say a resistor is connected, this resistance is RL, right, and voltage across this it is giving, suppose this is giving plus and this is minus, this V0 is equal to actually V2, because it is connected across the your resistance R2. So, naturally whatever voltage will be there across RL, it will be the same voltage as V2. So, across the RL, this RL voltage is actually V0, so and it is connected across that your resistor R2. So, V0 is equal to V2, right. So, this is the circuit, is given. So, let me clean it, right. So, this is the problem. So, therefore, resistor RL acts as a load on the voltage divider circuit, right. Now, what we will get, you have to find out V0 is equal to, now with the load RL connected, the expression for the output voltage becomes V0 is equal to Req plus your divided by R1 plus Req. So, I am making it here again, how it is coming, right. Here write up is little bit more, that is why getting less space for making this connection. So, question is that first I will do it, I will clean it, So, this is your voltage source, right. So, you have the circuit like this is R1, this is R2, right, and here your load resistance is connected. This is making in short, this is R1, R2 and this is your RL, right. Now, this R2 and RL, it is in they are a parallel, right. So, that means equivalent of this R2 and RL, Req will be equal to R2 into RL divided by R2 plus RL, because R2 and RL they are in parallel, just we have seen the parallel resistance. So, they are in parallel. So, Req of R2 and RL equivalent is Req is equal to R2 RL by your R2 plus RL. Then and current flowing through this is I, this is your I, this is the current and voltage here is V, right. So, then further its equivalent circuit, I am just trying to make it here, just see this, this is your voltage V, therefore, this resistance is R1, right, and this equivalent resistance of this is Req and this is the current I. So, I will be is equal to your what you call that I is equal to, I am making it here, that I is equal to, it will be V divided by R1 plus Req, right. This is your I, this current is I, right. So, this V upon your R1 plus Req, right. Then what will be the your V0, right. V0 is equal to, so this I V0 is equal to what will given, it will be Req into I, because this equivalent, this is your Req, this voltage V0 is equal to V2, this was plus, hope everything is understandable to you, this is minus. So, this voltage was given V2, right, and V2 is equal to writing here, and V2 actually is equal to your V0, right. So, that means where to put it, I have to find out some space. So, making it here, right. Therefore, V2 actually V2 is equal to V0 and therefore, V0 that is equal to V2 is equal to your I into Req, right, because this is this I current is flowing here. So, V0 is equal to V2, right, V2 is equal to V0. So, V0 is equal to Req is equal to your V2. So, I into Req. So, it is your this is your this I current is this I is flowing through this circuit. So, I is equal to V upon R1 plus Rq. So, if you put I is equal to V upon your R1 plus Rq, you will get that your what you call Req upon R1 plus Req into V, because I is equal to V upon R1 plus Rq. So, here it is Req into I. So, V upon R1 plus Rq into your Req upon R1 plus Rq into V. So, this is equation 1. Hope things you have understood, because write up is more. So, finding somehow I am making it here, hope things are understandable to you, right. So, where Req is equal to, I just derived for you R2 RL upon R2 plus RL, how it is coming I have told you. So, this is equation 2. So, let me clean it, all right. So, equation 1 and 2. So, from equation 1 and 2 you will get, so here Req we got R2 RL upon R2 plus RL, here you substitute Req is equal to R2 RL plus R2, here numerator Rq and denominator also R1 plus, here you substitute Req and simplify little bit. If you simplify, we can write in this form that V0 is equal to R2 divided by R1 into 1 plus R2 upon RL plus R2 into V. This is equation your 3, right, and or V0 by V, take the ratio of this V0 by V, that means divide both sides by V, it is becoming R2 upon R1 into 1 plus R2 upon RL plus R2, right. That means equation 4 shows that as long as RL much greater than your R2, the or R2 is negligible, suppose R2 is very small compared to RL, right. For example, just hold on, right, when R2 is very small compared to RL, here I am writing RL is much greater than R2, that means other way R2 is much less than RL, right. If it is so, that means R2 by RL, it will tend to actually 0, approximately 0. Therefore, V0 by your what you call your in that case this and this R2 is also neglected. So, in that case what will happen, that V0 upon your V, it will become essentially undisturbed, because in that case what will happen, V0 upon V, if you follow this, the R2 is neglected, but the R2 is very small compared to RL, right. So, this term should not be there and this term also should not be there, right. So, basically it will become your, if we do not this R2 upon R1, right, such that V0 by V is essentially undisturbed by the addition of the load on the divider. So, I mean you have to make little bit of your what you call some understanding that R2 is very is your what you call. So, as long as RL much greater than R2 or R2 is your very small compared to RL, right. So, that means your that means this term you can eliminate, otherwise this will be, if it is too, if it is totally neglected R2, then it will become R2 by R1, otherwise this term can be eliminated compared to 1, because if this is very small compared to 1. So, ultimately it will become R2 upon R1 plus R2. If your R2 is too small, right, compared to R1, then you can neglect, it will become R2 upon R1, otherwise if R2 is compared to RL is much smaller, then this term can be eliminated, right, this term should not be there, and compared to, because 1 plus 0.00 something may come. So, it will be approximately R1 plus this R2, let it be there. So, in that case R2 upon R1 plus R2, but if R2 is also very small compared to R1, then it will be R2 upon R1, but R2 is very small means in that case V0 by V ratio will be very small, right. So, this is some kind of understanding. Okay, let me clean it, right. So, take one small example. So, this example one small exercise will be given for you. It is given the resistors used in the voltage divider circuit shown in figure your 33 have a tolerance of plus minus 5%. So, find the maximum and minimum value of V0. You have to find out that all the resistance tolerance is given plus minus 5%. It is given, it is a simple that voltage divider circuit, 100 volt source, it is across R1, voltage is V1 and resistance R1 is equal to 25 ohm, and this one V2 resistance R2 is equal to 100 ohm, and same as before that V0 is equal to V2. So, you have to find out that maximum and minimum value of V0. What will be the maximum value and what will be the minimum value? Tolerance is given plus minus 5%. Now, one thing I have written, but it is an exercise for you, I have not done it here. That is, from that the maximum value of V2 occurs when R2 is 5% high and R1 is 5% low. Why? That you find out yourself, right. This is an exercise for you. Similarly, the minimum value of V2 occurs when R2 is 5% low and R1 is 5% high. This is also you find out. Note that V0 is equal to V2, because earlier just now when your load resistance RL we connected, we have seen that it is V0 upon V2, right. So, question is that maximum value V2 occurs when R2 is 5% high and R1 is 5% low. Why? You find out, right. Similarly, minimum value of V2 occurs when R2 is 5% low and R1 is 5% high. From your intuition you find out. This is not solve here. Why? This is an exercise for you, but in that case what will happen, that 5% I told that V0 max will happen that when your R2 is 5% higher, R1 is 5% low. So, R2 is 5% high means it will be 105 and your R1 is 5% low, that means it will be your 23.75, right, whatever it comes. So, that is V0 max will get 81.55 volts. Similarly, for V0 minimum it is 5% low and 5% high. So, it is actually 95 by 95 plus 26.25. So, 78.35 volt. That means, it has been asked that you find the maximum and minimum value of V0. Therefore, minimum value of V0 will be 78.35 volt and maximum will be 81.55 volt. That max mean 5 increase or your what you call that your decrease, that it is from your intuition you please find it out, right. So, that you do little bit exercise, mathematical exercise, little bit see the circuit, right. Now next is another problem, determine that Req for the circuit shown in figure your this 34. So, you have to find out that your what you call your equivalent resistance of this circuit, series parallel circuit. You are looking from left to right, that is, this is your Req, this is your Req, right, not marking by color ink, but this is your Req, this is your equivalent, this is a simple circuit is given, you have to make that your what is the equivalent Req of the circuit across the terminal, across these two terminal, this is one and this is another one, across these two terminal you have to find out, right. That means just okay, just for your this thing, this is suppose R eq means you have to find out across this what is the equivalent your resistance, what is the equivalent resistance across this terminal or this thing R eq, this is your R eq, right. You have to find out looking from left to your what you call right, right. So, how will do it? Let me clean it. So, here 2 ohm, and if you look that 2 ohm and this 2 ohm and 10 ohm, these two resistance are in series, right. At the same time this 12 ohm and 6 ohm, they are in parallel, right. So, 10 plus 2 it will be 12 and 12 6 they are in parallel. So, 12 into 6 by 12 plus 6, so 72 by your 18, so 4 ohm, 4 ohm again will be in series, and again this 8 ohm will be in parallel to 12 ohm resistance. Now, see how is it, right. So, before going to that I am making some calculation for you. So, this is your 8 ohm resistance, this is your terminal, this is your 8 ohm resistance, right. This is your 4 ohm, and this 12 and 6 they are in parallel, right. So, it will be your equivalent will be making it here, it will be 12 into 6 by 12 plus 6, right. So, it will be 72 by 18, that actually is equal to your 4 ohm, right. So, this will be equivalent to 4 ohm, right, and this 2 and 10, these two are in series. So, 10 plus 2 it will be your 12 ohm. Now, further this is equivalent of this, this is equivalent of this. So, further this is your 8 ohm and this is also 8 ohm, right, and here also it is 12 ohm. So, 12 and 8 are in parallel, right. So, basically it will be 12 into 8 96 divided by 12 plus 8 20. So, 96 by your 20 plus this 8, that is your what you call, that is your R equivalent, right. So, solutions are there next. So, I am just cleaning it, right. So, 12 and 6 ohm resistors are in parallel. So, they are equivalent. I just told you that 12 into 6 it will be 4 ohm, right, and similarly these two I told you 2 and 10 are in series. So, 12 ohm. So, this is the equivalent circuit. One more thing, here one 6 ohm resistance is there, I have missed it, right. I have missed it in the previous calculation, that here circuit, here one 16 ohm resistance is there, I have missed that one in the previous circuit, I have missed that one when I am making it by ink pen, I have overlooked this one. So, this 16 ohm is also there, right. So, anyway, so this is that equivalent 8 ohm, 4 ohm, 4 ohm, and 4 plus 4 are 8, your 8 and 12 are in parallel. So, it is that further the simplification, that 8 ohm, this 8 and 12 are in parallel and 16 ohm, right. So, basically this equivalent circuit actually it is, if you this one equivalent is, this is 8 ohm, right, and here it is your 16 ohm, and this 8 and 12 are in parallel, right. So, it will be 12 into 8, 12 plus 8, right, whatever it comes, 96 by 20. So, 8 plus 90, your what you call 96 by 20 plus 16, that will be your equivalent resistance, right. So, just hold on, right. So, 96 by 20 is 4.8 ohm, 8 ohm, sum it up all. So, R eq will be 8, because all are in series now, 8, 4.8, 6 all are in series. So, 8 plus 4.8 plus 16, so 28.8 ohm, this is the answer, right. Now, determine, now another example you take, determine R12 for the circuits, the circuit is given, again you have to find out the equivalent resistance R12. Now, before analyzing this circuit, just you have to little bit you have to see this, that how things are given. So, this is 10 ohm resistance, right, it is 1 ohm, it is 1 ohm, this 1 and 5, these two are in series. So, 5 plus 1 is 6. Now, this is a common node, right, this is one node only, this is node B, that is why here it is marked B, here it is marked, and these are not connected, this 12 ohm, 6 ohm not centrally connected, that is why it is shown that it is not connected, right. So, this is a common node. Now, if you try to make the equivalent, that from your intuition you can find out, basically this 4 and 12 ohm are in parallel. Similarly, this 6 and 3 are in parallel. If I read a little bit for your understanding, just try to accommodate here. So, this is your node 1, this is actually 10 ohm, right, and this is your node, suppose this is your C, as per this thing it is C, right, and this is actually your 3 ohm, and this one, this B, it is a common node, because B is a common node, right. So, that means this your what you call this C to B, this 6 ohm, actually it is in parallel. So, if I make like this, this is my B point, then your this 6 ohm also is in parallel to this your 3 ohm, across 3 ohm resistance, then that means this one actually 6 ohm is connected like this, right. Then it is 1 ohm resistance is here, this is your 1 ohm resistance, and this terminal is your what you call A terminal, this is actually 4 ohm, right, and then this A to B, it is a this 12 ohm resistance also parallel to this 4 ohm, that means this is actually your 12 ohm, right, and this is actually common node, right, this is actually common node, right, and finally this is actually common node, but basically they are circuit like this, and 1 and 5 they are in series. So, total will be 6 ohm. So, that means 4 and 12 are in parallel, because this is a common node, this is a common node, right, and but made it like this, such that your what you call, so your clear your, and this is of course this is your point 2, such that understanding will be clear. So, that means 3 and 6 are in parallel, 4 and 12 are in parallel. So, I am cleaning it, right. So, that means that when we write 12 and 4 ohm are parallel, 12 ohm parallel to 4, this way we write. So, that means 12 into 4 upon 12 plus 4. So, 3 ohm. So, just now I told you that your 12 ohm and 4 ohm parallel, similarly 6 and 3 are in parallel, similarly 3 ohm and 6 ohm are in parallel, just I told you. So, 3 into 6 upon 3 plus 6. So, 2 ohm, right, and 1 ohm and 5 ohm, these two are in series, equivalent circuit I showed you. So, this is 6 ohm, right, and therefore, after making all this simplification, this is your say equivalent circuit now. So, this is, it is 2 ohm, this is 2 ohm, but this is a common node, this is a your what you call, this is your common node, right. Now, here also if you look into that, 6 and 3 these two are in parallel, 6 ohm and 3 ohm these two are in parallel, right. So, if you further simplify, so 6 into 3 upon, I mean if you 6 or 3 are parallel. So, in this case your it will be 6 into 3 by 6 plus 3 is equal to 2 ohm, right. So, that is why your what you call, just hold on. So, that means with this, that 1 ohm will be in series, right. If these two are parallel, though it will equivalent to 2 ohm, as soon as with that 1 ohm will be in series. So, 2 plus 1 that will be is equal to 3 ohm, because this 1 ohm equivalent parallel to equivalent resistance of these two parallel resistors is 2 ohm, with that 1 ohm will be in series. So, total will be 3 ohm. So, I am cleaning it, right. So, if you look into the circuit, that is why it is 3 ohm, with that 2 ohm are in parallel. So, this is 10 ohm is there. So, 2 and 3 are in parallel, with that 10 is series. So, it will be 10 plus 2 into 3 by 2 plus 3, right. So, 3 and that is your here it is your what you call this thing. So, this is already 3 ohm, I told you that how we are calculating, this is I have told you, and now 10 ohm plus 2 and 3 are in parallel, this all these things I have told you, the 3 ohm equivalent 1 plus this thing, right. So, and this is 10 plus 2 and 3 are parallel. So, 10 plus 2 into 3 upon 2 plus 3, it comes 11.2 ohm, this is the answer, right. Hope things are understandable to you, right. Now, this is another circuit, you find R12 in figure to your 38. So, here also this circuit is given, that from here you have to find out your what you call R12. Now, look at the circuit, right. If you look at the circuit, you have to find out what is R12. Look at the circuit, that 5 and 20 these two are in parallel, because they are connected across your what you call that same terminal A and B, right. So, the equivalent 5 and 20 are in parallel. So, 5 into 20 upon 5 plus 20, so 4 ohm, right. So, if you draw the equivalent circuit, right, then this 4 ohm, this equivalent of 5 and 24 ohm, and it is connected with 1. So, 4 and 1 they are in series, right. So, look into that, 4 and this 1 ohm, rest remains same as it is, right. Rest whatever it was there, 4 ohm, 18 ohm, 9 ohm, 20 ohm and 2 ohm, there and their node numbering marking, everything remains same. So, 4 and 1 these are your what you call in series, right. So, it will be now your what you call 4 and 1 5, and this 5 ohm resistance and your 20 they are in parallel, because they are connected across the same terminal. So, that means it will, that means 4 plus 1 5 ohm, this is your, sorry, just hold on, right. So, this is 4 plus 1, this is your is equal to 5 ohm, this is series, and across this is 20, with that 5 the 20 are in 5 and 20 they are in parallel, because they are connected across the same terminal. So, it will be 5, equivalent will be 5 into 20 by 5 plus 20. So, 100 by 25, that is equal to actually 4 ohm. So, equivalent of this part is equal to actually 4 ohm, right. So, let me clean it, right. So, that equivalent is 4 ohm, right. This whole equivalent is 4 ohm, and therefore, this 4 ohm and this 2 ohm is here. So, with that 4 ohm equivalent 4 ohm, 2 ohm is in series, but do not confuse with this 4 ohm, 4 plus 1 5, 5 into 20 by 20 plus your what you call 5. So, 100 by 25 is equal to 4 ohm. So, this equivalent 4 ohm and 2 ohm are in series. So, that means in this circuit 9 ohm and 6 ohm, right. If you see, this is a here 18 is given. So, if you see into this, this is actually common, this is actually a common point, right. So, that means, and 4 plus 2 is 6. So, 6 ohm 4 plus 2, right, is equal to 6 ohm. So, 6 ohm, 9 ohm and 18 ohm, all three are in actually parallel, right. So, I am cleaning it. So, if you look at the next circuit, so 6 ohm, 9 ohm and 8 ohm parallel, right. So, find out the equivalent of this 6, 9 and 18, we told you know how to find out that it is your the equivalent of this, that 1 upon Req is equal to 1 upon 18 plus 1 upon 9 plus 1 upon 6, right. From that you find out Req is equal to how much, right. So, I have calculated. So, these all three are in parallel. So, 1 upon Req is equal to 1 upon 18 plus 1 upon 9 plus 1 upon 6. So, let me clean it, right. So, with this, that we have written 18 parallel to 9 parallel to 6, this way writing, equivalent comes actually 3 ohm. So, 4 plus 3, so it is 7 ohm, right. So, answer will be R12 is equal to 7 ohm. So, with this some 2-3 examples show how to find out your what you call that series parallel your combination of resistance. Now, question is that in the circuit problem you may encounter something where apart from series or parallel combinations, there will be some circuit where you cannot reduce the circuit such a simple form of equivalent resistance. Sometimes some 3 terminals will come. So, in that case you have to what you call obtain the equivalent your resistance. That is very important, because in circuit analysis and particularly in engineering branch, electrical engineering branch, these are very necessary. So, in that case we use that your 3 terminal, you have to, in many cases you will find 3 terminal resistances, 3 terminals coming, and in that case you have to find out series parallel combination may not be completely applicable there. So, in that case what will happen, you have to find out some other means such that you can solve this circuit. So, that is why in that case what we follow star delta transformation or delta star transformation. Sometimes star we call T network also, sometimes delta we call pi network, right. This way star delta or delta star transformation. So, next we will go to your star delta transformation. Thank you very much.